So this is a little different, and I will try to make it quick and not too complicated. So I was asked a few times what is the difference between an NPN transistor and what is similar for N-channel Mosfet. Let's call it just N-channel because we have the arrow and I never understand where the arrow will go in or out in the N-channel. So we have the bipolar transistor and we have also so this is the bipolar and this is the Mosfet. So how do they work, what is common and what is different? So let's do it like this. So we have also a PNP, this is called NPN, and this is called PNP, and we will get to the difference. And we also have the P-channel Mosfet. Okay, so this is more or less like this or similar. There are of course different things, and this is similar to this, and I will explain how to make it work. So to make the NPN work, we need to give something that is called VBE, or a voltage between the base. This is called the base, this is the emitter, and this is the collector. Here this is the emitter, this is the base, and this is the collector. On the N channel this is called gate, and we have a source and drain. So let's call this source and this drain, and on the P channel we will call this the source and this the drain, and this will be the gate. Okay, so in order to make the NPN work, NPN can be like a regular switch. So both of them, we can work with them like a regular switch. So they can open and close and connect a current to our load. In the NPN, what we have to do in order to make it work is to get something that is called the VBE, and the VBE is generally around 0.7 volt. So if the base will be 0.7 volt above the ground, this is very important to be above the ground, so it will conduct and there will be current flow. In order to that the current will flow, we need to connect the collector with our load to the VCC, because if we are not doing all the things, it will not work. In order to get the VB, usually what we are doing, there are different ways to do it, but the simple way is just to put divider of resistors, and this will obtain the 0.7 volt in order to make it to work. Okay, and in the NPN transistor we have some formula. For example, we have IC is equal to beta IB. IB is the current that is going to the base, and IC is the current that flow here. And IE is equal to IC plus IB, because we have also the current from here and the current from here, and they both go this way. Okay, so we need to apply a positive voltage. It should be positive from this point to this point. So this is pretty similar to the N channel. In the N channel we have also a source that we should connect to our ground, and also we have the drain that we can connect it to our load and then to the VCC. And here, in order to make it work, we need to obtain something that is called VGS. Well, this is a voltage between the gate and the source. The difference between those is that the current here flow through the base to the transistor. Here this is a little different. It's like a capacitor, and when the capacitor is charged, we take it time. It depends on the Mosfet itself. After it is charged, you don't have to do anything. It will conduct and the current will flow, and there is no current through the gate, because when it is fully charged, so there is nothing that flow here. Okay, in order to do to make it work, you can do the same. Use two resistors in order to divide the voltage between the VCC and the GND with a simple formula, and then you can make the VGS. The VGS is usually around 3 volts. It can be higher, can be lower, but generally it's around 3 volt. So you have to be greater than 3 volt in order to conduct, and the current will flow this way. Okay, in the P channel MOSFET it's the same, but the VGS is now from the positive side, which means the source is connected directly to our VCC, and the drain will go to the load and then to the GND. Okay, so here we have our load, and again, in order to make it conduct, now it needs to be a VGS, but from this point to this point. So VGS is now, in respect to the VCC, will be negative, because if we have, for example, here 12 volt, so we have to apply to the gate 9 volt in order to make it work and conduct and be exactly like a switch. So again, here we can put divide of 2 resistors, and we can calculate it very easily, because let's do one example. This is R1 and this is R2, so VR1 is equal, of course, to VCC divided by the 2 resistors R1 plus R2, and this is all multiplied with, in this case we want to calculate the voltage here. Okay, so the voltage on the gate is exactly the voltage on R2, so we have to multiply it with R2. On this, in this example, we will have to multiply it with R1. So let's do it one time. So VR1 is equal to VCC divided by R1 plus R2, and this is multiplied with R1. Okay, so this is the basic formula in order to conduct. On the PNP, it's similar to the P channel, and in order to make it work, so we can connect the emitter to VCC, and then the collector will connect to our load and to the GND, and then we have to have VBE, which is respect to the VCC here. So we have multiplied with 2 resistors, and we can calculate it in the same manner and to see what is the exact voltage on R2 in this case, in order to make it conduct. Here again we need a 0.7 volt between these 2 pins, between the base and the emitter, in order to make it conduct and the current will flow. There are some minor things that we need to be aware. In order to work in the switch way, so we need to have a VGS that is greater than 3 volt, because generally MOSFET have also resistance that can be similar to this NPN, that can work as amplifier and not as a switch. So this can work as an amplifier or as a switch. Also this can work as amplifier or as a switch, and the difference between those is, of course, the voltage that it can handle, the breakdown voltage, the current that can flow. There are MOSFET to high current, and there are transistor to high current, and there are transistor to low current, and there are MOSFET to low current and to low signals. So this is the common and the different things. In a few minutes, I don't want to discuss more to detail. Hope it will give you some clue, because someone asked me how this goes. So thank you and bye.